Hello and welcome back. My name is Corey, and this is the series where we are building a programming language from scratch. That is 100% live coding with all of the mistakes, all of the syntax errors, but also you seeing real time what it takes to develop a large complex program. We are developing a programming language named Tang, stands for template language, and it is we're writing in C++ using hopefully modern C++ where appropriate, and using tools such as my brain just kind of stopped working. It's too early in the video for this to happen. Yeah. That's okay. Using tools such as Bison, Flex, ICU, Google Test, Doxygen, and of course our editor of choice is Vim. So this is bare bones in the terminal writing code, and we have it's starting to be a respectable language, but it's missing some things that any respectable language needs. So we're going to look at first, we've already got floats, we've already got integers, we've got booleans, we've got our 5 mathematical operators, we've got our 6 comparison operators, 6 comparison. We've got a null type. We've got type casting. We've got object pools. We've got errors now that can percolate up. Is that the best way of saying that? I don't know. Anyway, it can pass up through the system. Okay, we've got all of that stuff, and now we need to add if statements. And I've been waiting for this. We got variables and assignments. Yeah, I forgot that because we needed that before we could really do if statements. We don't have any way of printing out variables. Right now we're still like just returning the very last computation that was performed. But aside from all that, we're going to have if statements today. May take a little while, but we're going to jump in. And with that, here we are. As I've always said, nothing up my sleeves. This is just, if I say get log, you see that the last thing that we did was the episode for number 25. That was a previous episode. And if I say get status, it says there's nothing there. We're going to start at that point. Now, we want if statements, right? And we get to choose how we want the if statements to behave, what we want it to look like in the language. And there's a problem. I'm just going, let me pull up this Wikipedia article. There is an article here, and it's about the dangling else problem. It was tried to make it large so that you can see it. The dangling else problem is the problem of, usually if statements can be if something, then something else. If B, then else one. If B, then S1, else S2. And that's fine. The problem comes is if you get a statement like this. If A, then if B, then S, else S2. And the question is this else S2, what is it associated with? Is it like this first example where the else S2 is associated with the alternative of not A? Or is it associated with the inner if? And we have to decide which one we want. And you see here that it dates back to Algol 60. So it's been around for a while. And it's a little tricky in the grammar. It's a solved problem. We know how to do it. The problem is not a lot of people understand the solution. And so it's a problem when you get to grammars. And yeah, we're going to talk about that today. And this talks about, there are ways of doing it. If you require begin and end statements like Pascal does, Pascal. Why did I call it that? Well, actually, I know why, but doesn't matter for this video. Or if you require curly braces, but we don't necessarily require them, at least we're not going to. So we will use a very carefully picked syntax thing in order to do it, and in order to enforce the way that we want to have it parsed. And it has a section on it. But the problem is this doesn't exactly tell you enough information to handle all the use cases, because we don't need this for just if statements. We need it to also take into account other structures that might have stuff after it that's not followed by a semicolon, right? I think while statements and are ranged for that we'll get to. I mean, there's other things. And then where do regular statements fit into this? Well, okay. So we will be using this idea of an open statement versus a closed statement. An open statement is one that does not have an ending else. Okay? A closed, or excuse me, yeah, it doesn't have an associated ending else. And in this case, excuse me, it can only end with an open statement. So an open statement can only end with an open statement. And it can contain a closed statement for the inner one. And then what is a closed statement? Well, it can end with a closed statement. And a closed statement also, it says non-if statement. So there are other things that can go in there, like just a statement with a semicolon at the end. The problem is the word statement is kind of overloaded in programming, and it can mean a lot of different things. It means something particular in our grammar. Does it mean the exact same thing that it's talking about here? Yeah, don't worry. We're going to do this. So and I can even see this being a problem if expression closed statement. No, never mind. It would work. Sorry, just realized something. And it shows you examples of things that are less than optimal in this. But anyway, okay. I will link to this. You can read through it, and it's a worthwhile problem to be able to think about and to think through. But we'll get there. I'll show you my solution for it. And let's just jump in. The first thing, I know we're going to need flex, and we're going to need bison. We're going to need not our source, our include, our opcodes. And so we're going to add an opcode, and then we're going to add an AST node for the if statement. We'll do that. Do we want to do it later, or do we want to do it first? You know what? Let's do it first. Told you this is unscripted. So in order to do that, we're going to copy a source. And what would be a good one for the if statement to copy? The if statement has 2 or 3 parts. I want to double check. It deals with the whole fact that I'm using shared pointers now, and I just need to double check the way something could be written. So one moment. Yeah. Okay. I realized something we're going to have to do, but that's okay. Sorry I made you sit there for a minute. Okay. Let's just copy the... Well, it doesn't... Well... I think the unary will be AST node. Unary will be the least amount of work. Source slash AST node. And we'll call it if else. Yeah. If else dot CPP. And we will copy the include for AST node unary, and that will be include AST node if else dot HPP. And let's also edit our make file, and we know that we're going, so we've got this AST node block boolean cast float, so it's going to go after the cast, right? And we're going to call this if else. All right, and looking for cast, and it's going to go after that. So, oh, I've forgotten to look up how to do the relative numbers. Oops. Slash, and this is going to be 101 comma 102, and we're substituting cast for if else. What did I do wrong? (101, 102) substitute cast for if else. Lovely. Yeah. Don't know what I did wrong before. I guess I can go back and watch the video, but oh well. I'm going to turn on the fan because it actually gets pretty hot up here. Okay. So that exists. The make file exists. Let's edit the include of AST node if else and source AST node if else. All right, now we're going to %s, and this will be unary will become if else. Unary will become if else. Okay, and go to the next one, and we're going to repeat that, all caps. That's fine. The other one, there we go. Okay, going back to the .hpp file, and that represents an if else. Well, I'll just say if else statement. M-E-N-T. If else statement. Okay. And I don't need the type of operation, so that can go away. My constructor, now this is where it's going to get interesting. So I don't need the operator, but we're going to have more than one of these. The first one, yeah, we're going to have 3 of them. And so the first one is going to be the condition. The second one is going to be the then block, even though we're not using the word then. And then the last one is going to be the else, E-L-S-E, the else block. And then, of course, has a location. So we're going to need this again. Well, okay. We don't need this one here. That's going to be deleted. This is the operand to which, no, it's not. This is the condition which determines whether the then block or else block is executed. And I've gone past the limit. No. Okay. And yank 3. Getting my spacing. What did I call this? I called this the condition. I called this the then block. And this one I called the else block. All right, now let's there's a dump and there's a compile. Okay, I think that one's in pretty good shape. The only problem is, well, let's do these. This is going to be the condition. And that is going to be, well, it's the same thing. Okay. This is the, sorry, I'm looking for it, the then block, and it is when condition is true, and else block is the expression executed when condition is false. All right, and I need to put that there. This is not just an expression, it's a statement. I think so, yeah. Executed when is true and this is the expression. All right, so let's go. That condition is the expression which determines. This should be the statement executed when, no need to leave out the articles. Okay, there we go. Now we've got our documentation sorted out almost. Not every if else is going to have an else, right? So do we want to do that as a, yeah, we're going to do it as another constructor. Easily enough, especially because we can just do that and just delete the else block. Okay, let's go to the .cpp file now. And it's condition, then block, else block. Okay. So we changed these, but we're having to do some work. So This is going to be condition. Then block. Else block. Whoops, capitalize. And now ASC node location. I'll just do condition, condition. Then block is then block. Else block is else block. And all right, now we need to copy that and remove the else block. Well, we've got to set the else block to something. And what is it in C++? I should know this, but I'm old and forgetful. When C++ shared pointer null. That's what I want. I just want to know what it's called. Come on. Yeah. Oh, just give it no pointer. Okay. Okay. Now for the dump. Let's see. We need. This will be. We don't need this description. It's going to be indent plus if else. Okay, plus indent plus an additional indent, and it will be condition plus this, and it's going to be the then block dump of an indent plus 4 spaces because we indented twice for the condition. Plus an indent of 2, condition And by the way, if we really want this to look neat, we could do something like that. For each line. There's where the plus key is. Indent plus then block. There we go. And what's that going to be? That's going to be a closing quote. No, we need a new line there. Plus this oh wait this should be condition I know some of y'all saw it and you didn't tell me. How rude. Let's see. You know what? I think I want to say plus and do a test of this else block. How do I want to format this? So normally I would do this. Whoop. Or that. Okay. Why am I doing it this way? Well, number one, I don't mind the ternary. There we go. But it's the indent plus the then block, and then it's the then block. No, it's the else block. Do I want to do it that way? No, I think this is ugly any way that you do it. And I do prefer, you may be wondering why, I do always prefer putting the question mark and colon at the beginning because it makes it very obvious that this is a ternary. And then, of course, by the way, yes, I see that we need the closing parentheses. That's not a problem. The question is, nope, that should be there, and that was the wrong way. Basically, it says if there's something in the else block, then do the indent, which is a string, so it's going to be of type string, so the else of the ternary has to also be a string. Give me the indent plus else block, that's fine, and then the else block dump on a new line. Simple enough. So it's all one big line. Now the compile. The compile is the interesting part. We know that there's three parts to the compile. Let me just get them out there. We know that there is the condition, the then block, and the else block. Okay. I am maintaining this just as a just so that it's there. Okay. Now what needs to happen? Well, first we're going to compile the the block, but I need to look at the, you know what? We've got, no, I don't. I haven't opened it yet. You know what? WSL view, and this is our documentation. So it's docs, HTML index. There we go. Opened on the other screen, but I don't care. For the classes, I want the program class. And we have a is okay, so we don't have a way of getting at the bytecode. And we need a way to get to the bytecode. The reason is because what's going to happen is we've got to put, basically we have to evaluate the condition and say, is this true or false? And if it's true, then evaluate the then block. If it's not true, evaluate the else block. But that means we have to basically do a conditional jump, and yes. And we don't know where we're jumping to, so we can't add the bytecode yet. So we need a way to access the bytecode. There's no way of getting around it. Public attributes, the output, and the identifier stack, but we don't have access to the bytecode. And that scares me. We've got to add bytecode, dump bytecode, get code, get result. Okay, so we need to add something to our program. So edit our include of program.hpp, that's fine. And what are we going to do? How are we going to do this? So we've got our get code. No, that's not what we need. That's the bare script. We've got dump bytecode. So we've got this idea of get result that will returns a const garbage collected value. That's fine. Add bytecode doesn't do anything. Execute and our identifier stack. The problem is we need all of these compilation things to have access to change something in the bytecode. And it needs to be protected still. So what we're going to do is we're going to add a function that is called change jump destination. Okay, and it's going to take a parameter that is what am I using for, what is bytecode? There, evidently I can't type. I know it's defined. Oh, it's a vector. Okay, so that means its index is a size t, size underscore t. So the offset the location of the jump statement. That's fine. And the opcode address, okay, and then we'll say the jump target, and this is going to be the location, thinking. What it is, it's where we want to jump to. Return. That's going to be whether or not the location, sure, that's good. Okay, so this is going to return a Boolean of true or false, and we're going to call this set jump target. Set the address, no, of a jump opcode. Sure. And it's going to take in a size t, and we call that opcode address, and uint 64t, because that is what our vector is of, and that's going to be called jump target. And now if we edit our source program.cpp, we need to add this and whoops. And a couple sanity checks. If opcode address is greater than or equal to this is opcodes. Bytecode. Excuse me. Bytecode.size return false. Okay, first sanity check. The next one will be, we can't do it yet because we don't have the jump instruction, but so let's just say what our tests are. Verify that the is in scope. This one is going to be a jump instruction, and that's going to be to do. And last but not least, set the instruction. So this should not be that. It needs to be size -1 because we can't do it at the very end. Yeah. So set the instruction. What is the instruction? What's this going to look like? It's going to be this bytecode, opcode, address equals jump target. No, I misspelled that. Okay. And return true. There we go. So that should work. The other thing I want to do is anytime we add a bytecode, I want to return a size t, and that will be return this bytecode dot size. Because we're going to need that. So target, and where's the add bytecode? There we go. Size t, and that's going to be at return okay, that's fine. Now, so when we add a bytecode, we're going to get the size. And when we set our jump target, it's going to, we're going to be able to change something there. Oh, let's go back to that because I said opcode address, and it's really opcode address +1. Good catch. Glad you saw that. Now let's go back to our .cpp and look at how the compilation is going to happen. All right. So buffer2. Now when we compile our condition, that's perfectly fine. But now we need to jump to a so we'll say if condition is false, jump to the else block. Yes. So what will this look like? We'll say bytecode, and it's a uint 64t cast of opcode, and what will this look like? So it's a jump if false. And is it going to leave the result on the stack? It should consume the result. So there are going to be times where we need the opcode to consume, or we could just say it doesn't consume and it's our job to clean it up. We could say that. No, I think we want separate statements. Okay, so it's going to be JP jump if false, and I think, because again we have to decide what do we want our nomenclature to be. If there's two possible things, it could consume something from the stack or it could not, or it could leave it on the stack. You say, why would we want to leave it on the stack? Well, because of our logical and. If the first thing is false, you don't need to evaluate the second part, but you don't want to have to put it on the stack again. So jump if false and would an X mean consume? Sorry, I'm arguing with myself, but like I said, naming things is the hardest thing in computer science, and I'm doing this 100% live, or 100% live coding. I'm not following something else. Jump to the else block. And normally you wouldn't put a, but so I'm going to say well, what's our word? Pop. And it will pop. Okay. That's fine. That took a lot longer to get to than I thought, but that's fine. Okay, so we just have added this. So the idea is now we need to know where we're jumping to, and this line the condition false is going to be so the add bytecode is the size after that. So it needs to be this minus 1. Because think of it, if this were, for whatever reason, if this were the very first opcode, it would give us a size of 1, but we would want to point to 0. Condition false is there. Okay. Now, program.add bytecode 0, because that's a placeholder. Now, capital C, compile the then block and jump past the else block. Now we don't know where the else block is going to be, but okay. So the then block is going to compile but I think the compile needs to also return the size. Yeah, it's going to have to. The compile is going to have to return the size. Okay, that means we need to add it to all of our AST nodes. That's fine. All that I need to do is get the bytecode vector. And it's just going to be a const vector of, wait, can I just say bytecode? Bytecode with a capital B. Ampersand. Get bytecode. Now in program buffer bn, there we go. We did it right after the add bytecode, yeah. So we're doing it that way so that we don't copy stuff. And this is going to be okay. And now for the if else, all right, and now it's going to be program.get bytecode.size. Oh. -1. There we go. All right. Sorry. So the condition is set to false, jump to the else block. So this is that we're going to say jump if false with a pop. And if the condition is false, or the location of it is the size -1. Is that right? If there's only one thing there, it'll return a size of 1, but it's in position 0, so that's correct. Program.add bytecode, that is the that's the jump location. Okay, now we compile the then block, and now the question is, oh well, we can say the auto else block start is equal to program.get bytecode.size -1. The question though is there an else block? Or not, there is an else block. Okay, that's fine. And so we will say this as if this arrow else block, if it does exist, then nope, didn't mean that, I meant that. The else block start is here. And now I would say program dot, what did I call that? Set jump target. Set jump target. Okay. And the opcode address and the jump target. That's fine. Program dot set jump target, and what is the opcode position? That is condition false. And where are we going? Else block start. Okay, so it's going to jump to right here, and now we just compile it. Now there's something else that we have to do, and that is we must tell the then block to jump past the else block. They've got to do a little leapfrog. Simple enough. So how do we do that? Well, we say the auto, well, first we need to program add, you know what? Add bytecode, and it's no longer going to be JPF pop, it's just a jump. And you know what? I think I like JMP, jump if false. Yeah, and then this is an unconditional jump, and we need to know where that is. So we will say auto the then block jump is equal to program.get bytecode.size -1. Okay. Program.add bytecode 0. So that's just a placeholder. Now add the else block, and I think I made a mistake, and I'm going to double check this. So if the condition is false, jump. So the condition is false is there. Now the then block jump, we don't want it to jump to the last statement of the... Oh, wait. So that's the location of it. Yeah, okay, we're okay. We're okay. The else block start is going to be that. I know I could have used the then block jump, but that's fine. We're going to set the jump target. You know, I'm going to put that at the end. And now we will do auto else block sorry, what I'm again, you want helpful variable names, and basically I want to capture the end location of the else block, and we're going to make our the jump target of the then block jump to be that. So you know what? That's fine. It can be then block jump is program.get bytecode size. Now the reason I'm doing it like this is by this line here, what we're saying is we're setting the then block jump. What is the then block jump? That is, after I've done the then block, I need to jump past the bytecode, right? So we're jumping past it. We also need to set the jump target of the condition false to be the else block start. So I can now say set jump locations. Else should jump past the then block. Yeah, that makes sense. And how we do that? Well, we just say we no longer have else block start. We have program.get bytecode.size. Okay, let's double check our logic. Notice I'm actually putting comments here. Why? Because this is harder. A little bit more work. So we have our we compile our condition. That's what I meant to do. If it's false, we jump to the else block. Jump to the else block, or wait. How about we just say jump to the end of the if else statement. That's fine. Okay. Condition is false. We get that's the location of this jump false pop. And we add the bytecode of 0, which is our placeholder. We compile the then block and jump past the else block. So we compile the then because that's always going to be there. And then for the else block, If it exists, then we've got the then block there. We need to jump past it, so we add an unconditional jump, and we get that location by the size -1, and we add a placeholder. Then we add the else block, which is this is wrong. The else block is going to start right there. Why? Because that is one past the jump location. Yep, that's why we look over it. And now we compile it. And now we set the jump target of the condition false to be the else block start. And we set the jump target of the then block jump to be the current size. And I'm going to add the word jump here just to make it clear. There we go. And otherwise, then block has been compiled, and we need to just set the condition false jump to be past the. That is correct, I hope. Okay, opcodes. We need to add an opcode for jump, false, pop, and jump. Edit the include of the opcode. There we go. And where are we going to put these? We've got our peak poke. I kind of like putting these kind of control flow up at the top. So we're going to say jump, false, pop is going to be, there's going to be a piece, yeah, PC number, and it's going to pop val if false set PC to PC number. There we go. And here we're going to, this is an unconditional jump, and it is going to have a PC number, program counter, right? And that's just set the program counter to PC number. Okay. There you go. Jump and jump F pop after the poke. So now we need to edit the include for, not include, the source for program dump, and the source for program execute. Okay, so after the poke, okay, we're gonna steal this one, put it in there twice because we need to, what was this one? This was JMP, and it is in fact 2. And this one's going to be JMPF pop, JMPF pop. Okay. And now buffer next. Believe it or not, we haven't done the bison and flex, but we're actually pretty close. We've got our poke here. Let's copy that. Okay. So this is going to be our JMPF pop. And target piece, well, I'll just say it's target. We don't need to stack, oh, we do need to stack check of 1 because we're it's got to pop something. And now we're going to say auto, what's it called? This is our condition is equal to stack back, and we're popping it, so stack dot pop back, so we're removing it. And now, nope, we need to if condition, and we need to check if it is true or not. So how can we do that? It's a garbage collected value, and we need to know if it is true. Do we have something that will just say, hey, is this true or not? Is it enough to say double equal true? Should be. Should be. Our PC is going to equal target. There. Else, we just keep right on a truckin'. Okay, so let's double check this. So jump if false. If it equals false, we're okay. So we pop off the condition. We're saying if it equals false, then we set the PC to wherever we said to jump if it's false. Else we just, increment by 2 because that's what we're doing anyway. Simple enough. Let's do our pop, shall we? 7. Not our pop, our unconditional jump. Oh, was that first? Jump, then jump, pop. Okay. So this one here. Jump. Is there one more thing? Yes. If so, PC is equal to that. Simple. Very, very simple. Okay, for the moment, we need to just see if this compiles. Make clean, make test, and since I was messing around, something's gonna have broken. Yep, there we go. astnode.cpp source astnode.cpp. Oops. No, compile. It should be a void, and that should be dash watch. Okay. No. Unit. Uint, and that is in our astnode if else .cpp. That is buffer 4. There we go. Should have looked for the green text. Did it again on line 38. Because I copied and pasted, I'm sure. Oh, how did I do that? That's in our execute. Can I go buffer last? No. Poke, jump, jump, pop. I have 2 pokes. Oh yeah, I know why. Fine. I pasted it twice, and then I did the jump if false pop first, and I should have done the jump first. Okay, we're passing everything. Yay! Let's do Bison and Flex. That's what we need to do, and then write a test. So, what would our test look like? Let's do that first. Test.cpp, go down to the bottom, and let's just yank this. If else. And we're going to do this. What's our first one going to be? It is going to be A is equal to 1 if let's just say if true. A is equal to 2. And now A. And the answer should be, well, it should be a 2, but I'm leaving it as a 1. And I think I'm going to that. There we go. And I will say else A is equal to 3. And notice no semicolons. That's kind of the point. And the answer should still be two. I'll leave it as 1. But, and then we'll go from there. I'll leave that and worry about it later. These should fail. Good. Stack is empty because it doesn't know what to do with these if statements, and that means we need to add them to Bison and Flex. So let's start off with Bison, and as normal we need tokens. So we don't have any. Let's consider what all we need. So we've got these kind of keywords. Let's put one here. Token if. Token else. That'll be else. What about our curly braces? Token. I'm going to say L brace. And that'll be that. And then token R brace. Is that all we need? An if and an else and, well, the parentheses, but that's already there. That may be all we need for the moment. Okay. Let's edit Flex. Our pattern. So we've got our keywords up here. Null, int, float, true, false. Are there any at the bottom or are they all? Nope. Okay, that's fine. We'll do. I'll just put them up here. Sure, why not? If. Nope, that is not what I should have done. I should have done If, okay. Else. And if you wanted them to be like capital letters or something else, you could even use begin and end instead of left brace and right. This is where you do it. So this is going to be an else. And I kind of want to put the braces down here. Do those need to be escaped? Where are my... That's bison. My bison notes. Where's my flex notes? Flex. I'm pretty sure I do have to escape them. Yes, I do. I do have to escape them. Alright, so let's just steal these two. Yank 5. Okay, there, now here is the open brace, close brace. And this is going to be brace, brace. Again, should still be broken. Test should be broken because we haven't told Bison what the grammar looks like, and that's where we've got to worry about this open and close thing. And oh my goodness, you know, but. Oh, so why are they not broken? Because we've cheated. We told Flex not to throw errors when it doesn't understand something. We'll change that later. But for right now, we'll keep going with this. All right, program. I think I should have gone the other way. There we go. Now for the grammar. Okay. We have the idea of an open statement, but like it's uncompleted. It doesn't have a matching whatever, and a closed one. And so let's add a few things. First of all, these here, these types. Okay, I was looking for them. So we're going to need a type that is a standard shared pointer to a Tang AST node something. There's going to be about 3 of them. What all do we need? We need a code block. We haven't had that. Although we do have an AST node that represents a code block, we haven't actually created a code block as a standalone thing. Okay, code block is fine. What else? We've got statements. We've got a single statement. Statements is a vector. A statement is a single one. I think we need an open statement and a closed statement. Yeah. Open statement and closed statement. Now, what does that mean? So our statement so far, it's a little overloaded, isn't it? I want to look at this one here. For the statements. So this could be a series of statements. And I'm double checking here. So, well, okay. I know I want to do this. I want to do the code block. Did I capitalize it? I think I capitalized it. A series of statements. Yeah. So it would be code block is either an open followed by a close. Now what should that do? Because of the way we set this up, we have to create something as a statement. No, not as a statement, but rather it's just, I'm going to say a null, right? It's going to push on a null, and then because it's a standalone statement, it's going to pop it off. Yeah. You say, Corey, that's inefficient. It can be optimized out later, but for right now, it's a placeholder. Or we might have an open curly brace followed by statements. Oh, that's what we need. That's where I'm doing this wrong. Okay, I can do this. Sorry, arguing with myself. It happens. What is statements? It is a vector, right? It's a vector of shared. And then what we did up here is we said when I get that vector of shared, I'm creating a node block. And it's going to have a vector with nothing in it. That's what I think I want to do here. Forget the AST null. I think I'm going to do a make shared of an AST node block, and it wants to have a vector, standard vector, of shared pointer of AST nodes, right? That is empty. Oh wait, and what's its location? At 1. So an empty node block, so we don't have to optimize anything out. Now, what if we have multiple statements? It's pretty much the same thing, except it's no longer going to be that. It's going to be $2 because it's already. Okay, that should be right. So we've got this idea of a code block. And is it... oh, non-terminal is useless in the grammar because we're not referencing it anywhere. That's fine. So we're saying the code block can be open close or open with multiple statements. So no statements or one or more statements. Yes. Now, what about this whole open or close? We have an open statement and a closed statement. And this is where things get tricky. See, in my mind, we have this idea of a single statement being that. That's not really true. Well, not now that we know about the open and close stuff. So let me just back up. There should be an open statement, I'm sorry. An open statement, and it should have some stuff. And what would an let's just do that. Let's do the open statement. An if, open parentheses, expression, close parentheses, and then something standalone. And I think that this should be the word statement. Is that right? I'll leave it there for now. I'll come back to it. I think there's another one I need to do. This could be an else, but it needs to end with an open statement. So the open statements, wanted to get this right. Wait, where is it? I had my notes. Let's say these should only have an open statement as the last terminal. I think that's correct. I need to double check with this one. Now, okay, let me go ahead and write this part. I know that I'm going to return equals a standard make shared of an AST node if else, and what am I going to feed it? The at one at no, not one. The $, first of all, 1 2 3 is the expression. The $, for 5 is the statement, and its location we'll say at 1. Okay. This is pretty much the same, except for we have the open statement at the end, and we can add that as a $7. Okay, so we've got this open statement. What's the closed statement? I think I showed this a moment ago. Yeah, I did. Yeah. Yeah, that's what it is. These will only contain the command complete thing. Alright, so a close statement. What does it include? It might be an if, open, expression, and now a closed statement, else, oops, closed statement. Yep. And we are just going to do that. Now, how do we get to these? Oh, closed statements. They are things that there's no ifs, ands, or buts about. We know what they're going to be. So it could also be a code block. Did I capitalize that? I think I did. A code block. Now, it's just, if I don't tell it to do anything, it's just going to pass through. It could also be an expression followed by a semicolon. Now we've already got that up here, which means I'm starting to remember this now. You say, Corey, you weren't before? Nope. Closed statement or open statement. Yeah. And a closed statement could be any of these things. Is there anything else that I need to say? You know what? just for the moment, I think that we should also... No. I'm going to leave it at that. So now it's going to tell me what all I got wrong. Start at the top. If else was not declared. Okay, that's an easy one. If else. Shouldn't be this simple. I say something tells me it's probably not. Wait a second. Is that right? Where's my test? Where's my test? For 9. So this one, I'm saying it's a 1, but it says it's a 2, and it really is a 2. Yes. Right? It says it should be a 2. I said it was going to be a 1, but it's thinking it's a 2, and that's really what it should have been. A is equal to 1, but if true, is A is equal to 2, and then A. And then this one, A is equal to 2, else 3, and it still thinks it's an A. So it didn't execute the else. Yeah. Okay. So here's what I want to do. Let's replace that with a 2 because that's what it should be. Replace that with a 2 because that's what it should be. And now we're going to say if false, and this should give us a value of 1, and that should give us a value of 3, but I'm not... Oh, wait. It's going to say I haven't changed these, and I know I haven't. So that should be a 3. That should be a 4. This should be a 5, even though we haven't done anything with it yet. And this should be a 3. This should be a 4, and this should be a 5. P3. It says it should be... Oh, it got a failure. Let's look at the unaligned Tcache chunk in a malloc. That's interesting. Am I able to check this out? Cout p3 dot dump bytecode. Okay, so I'm just checking this. And it's not returning anything, but okay. So null val, that is the integer a, integer 1, poke it into 0, so or stack position 0, and then pop that 1 because the poke doesn't remove. Boolean false, jump if false to 14, and 14 is the pop. It should be 1 past that. Okay. Okay. And that's going to be in the compile, not execute in the compile for if else. So that's going to be buffer 4. So, all right, so if there's an else block, that's fine. So jump f pop 14 should have been jump f pop 15. What is jump f pop? That is the then block jump. Then block jump is set to size. Yes. Do you know why? Because there is, after this is compiled, it has to pop the result of it off whatever was on the stack. There should be something on the stack at the end, and what is that? So the way I'm approaching this is that every statement leaves something on the stack, and then there's always a pop. So whatever you've done, it's on the stack, and then you pop it. Unless it's the last statement, and then that value is what's returned. So in this case, I'm doing everything, and I'm saying jump to whatever the size is, but the size is going to be a pop instruction because I'm just done. So it really needs to be size. No. There. Size plus 1. Plus 1. There we go. I did write it. Did it? Oh, I clicked on it. That should have changed to 15. Did I not save it? No, I saved it. Sorry. Hey, at this point I'm kind of tired, so I know I'm making mental mistakes. But I wanted to get this out. Jump F pop. Oh, no. The size plus 1, this should be a the jump target of the condition false. Oh, that's right. Oh, but it's this one. It should be both of them. I think that's right. Okay. No more errors. Yay. Okay, and what's it saying? Let's go back to the test. Is it 9? It is. Okay. P3s. So pushes a 1, pokes it into stack position 0, pops, because poke doesn't remove it, so we pop it off. Because that's the end of the expression, right? There's a semicolon. Now, the Boolean false is the condition. Sorry, this one, the condition. And then we jump, if it's false, popping the false to 15, which is the load A. Sorry, load A. Yeah. And that should give us a 1, which it says it should, and it was reporting, I had said 2, but it was saying no, it should be a 1, and that is correct. It should be a 1. And now let's do this with 4. Pretty sure that it's working correctly as well. I just want to do this. Okay. This is again all the same. Jump if false to 16, because it has an else. And what are we saying? A is equal to 3. So at 16, integer 3, poke that into memory location or stack position 0. Pop it because poke doesn't pop. And then reload 0. Now, by the way, yes, it can be an optimization that we could look for the pattern. Poke something, pop, and then peek whatever we poked, right? So we could get rid of those 2 commands. But anyway, we would have to adjust where we're jumping to and everything like that. But those are all optimizations. Those are all possible. Not worried about that. Now, let's see. If it were true, that means this would have not jumped. It would have done integer 2 load, poke that into 0, and then jump to 21, which is past the pop. Wait, is that right? Integer 2, poke. That would have left something on the stack. That would have left something on the stack. Integer 2, poke, and it is our job anytime we have a code thing to clean it up. Yeah. So we should have added an op pop right there. After the poke, we should have popped it, and then we should have jumped. Okay, let's do that. We should probably have an assert that says the stack size is whatever on this. I'll consider that for the future. But which one am I going back to? 9 is my test 4, buffer 4. And so what was that condition? We had an else. After the else, we compiled it, and now we have to add a bytecode that is uint 64t opcode pop. This is just cleaning up after ourselves. So buffer 9, it's not liking that now. Why is it not? Did I put it in the wrong place? It's, oh, I put it after the else, and it should be after the then. And you know what? I'm going to say from the okay, and I should have not done that yet, but that's all right. Buffer 4, buffer 9. There we go. All right, so what does it say? Poke 0, pop it, Boolean false, jump if it's false, and pop to 17. 17, so this is the false, it's going to be an integer, poke, pop, and then peek to reload it. That's fine. If it's not false, that is, if it happened to be true, what would it have done? It integer 2 load, poke that into 0, and pop it. That's the pop that we added. because it was just one statement. And now jump to 22, which is the peak. That is correct. That is correct. Now, we need to do the same thing with curly braces. And we're going to yank 7. And this is now a 5, 6, 7, 8. The good news is we're almost done. 5, 6, 7, 8. Oh, and I never looked, did it? It said it didn't pass, but because it thinks it's a 3, and I said it was a 2. And the correct answer is it should be a 3. So it's computing correctly. All right, now, I'm going to say B is equal to 2, and A is equal to A plus B. B is equal to 2, A is equal to A plus B. A. B is equal to 2. A is equal to A plus B. Whoops. Else a single statement. B is equal to 3, and let's say A is equal to A plus B. All right. Say, Corey, this is getting a little messy. Yeah, I know. All right, so this, or I was checking something else, and it's gonna, oh, no, it didn't complain. Don't know how to add these values. What? So we're going to do, we did the first 4, and it doesn't like P5, so we're going to comment out everything after P5. And do a cout p5.dump bytecode. Be nice if I we'll see what it says that it's doing. Okay, null val. Now the question is, why didn't it give me a place for B? I'm already seeing there's not, it didn't push. And the reason is, I know why. The AST node says, an AST node must have that compile script. So Do I have an AST node source? Include AST node? No, I don't. So edit include AST node.hpp. All right, and we're looking for is the right here, compile identifiers, and now we need to put that in the if else compile identifiers, and it is an override. Okay, now it's not in the CPP, but that's fine. We're about to do this. The B is inside the code block. The code block, in fact, if we look at the code block, edit the source for AST node block, the compile, I'm just going to yank it. And it calls oh no, not compile identifiers, sorry. It goes through all of its statements and it says, hey, give me everything in there. But the if statement's not doing that yet. So we need to call this for all of the parts of the if statement. And that's going to be in the buffer 4, compile, and let's just put it down here. Compile identifiers. And all that we have to do is this arrow condition, this arrow then block, and last but not least, if this arrow else block. Just do that. Okay. There we go. Non-member function. What are you talking about? AST node if else. There we go. We're not getting the thing where it just crashed earlier, so that's good. And are we in buffer 4 or buffer 9? There we go, buffer 9. And it says it should be 3. Is it? If true, B is equal to 2 and A is equal to that, it should be a 3. And if we check what it's doing, it's reserving a spot for an A and a B, integer 1, and poke that in memory slot 1, pop that, Boolean true, jump if it's false to 24. If we were, 24 would just be load memory, but it's not true, so it's going to keep going. Integer 2, poke that in memory slot 1, which is B, pop, and now peek the A, peek the B, add them, and poke that back in A, and pop, because that was the that was the last statement, so it would not have added the pop, but then we add a pop, and then reload A. And again, this poke, pop, peek could, since it's all the same, could be optimized out. But that is correct. It should be the 3. And now, by faith, we will run these, and it's probably going to still fail. That's fine on 6 and 8. So 6, it's A is equal to 1. If true, it should be now 4. And yes, it says it should be a 4. And 7, if 1, false. So it should have skipped all that, and it's still a 1, so that was correct. 8, 1, if false. Now we've got a code block, b is equal to 3. It should be a 4. And it says it's a 4. Okay. All of our tests should pass now. Now, we're going to change something. Notice we did no code block, no else, and true and false, right? We needed to test both paths. And then we did code block in both places. If we wanted to be thorough, and we do, we want to check the mixture. We want to say this one has a code block, that one doesn't. Or the if statement doesn't have a code block, the else does. Okay? That's just being thorough. And in order to do that, what is the fastest way? So the fastest way is to just do it, Corey. P8. So if false, that's 2, 3, 4, 5, 6, 7, 8. Okay. This is going to be 9, 10, whoops, 11. Nope, that was 12, 13, 14, 15, 16. So I've got to do that again. This would be, there it is, 9, 10. No, I hit replace instead of insert. 10, 11, 12, 13, 14, 15, 16. All right, now we just have to kind of mix and match this. So I'm going to say so starting with 9, we'll say this is just 8 is equal to 2, semicolon. And now this should not have an else. Oh wait, I already tested that. So there's fewer than I need. There's fewer here than I need to do here. Let's see. I don't need that one. Yes, I'm going to have to renumber. I don't care. Nope, that shouldn't have happened. There we go. I knew what I was doing. that I hit the wrong button. Actually, I want to do it here. So we've got a true and a false. The true, it should be a 2. The false, it should have a is equal to 1. If false, b is equal to 3, a is equal, so it should be 4. Okay, the next one I don't need. Is that right? Okay. So be a true, and I've got a statement here, and else a is equal to, what was I doing before? 3. It should be, I should do 4. Okay. And then this one is if false, a is equal to 4. Okay, so if it's true, it should come out equaling 3. If it's false, it should come out equaling 4. And then the last one is going away. All right, so 7, 8, and now this one should be 9, 10, 11. Did I just do that wrong? No. X 9. This should be 10. This should be 11. And then this should be 12. And this should be 12. Okay. All those should pass. They do. Always happy about that. And now I want one more test. You say, Corey, really? Yeah. Well, 2 more, but one's for true, one's for false. So, I know I just deleted all that. The reason is I want to say A is equal to 1. B is equal to 2. If true, A is equal to B. If false, no. Oh, am I going to do it if true? That's what it is. Okay, sorry. If true, A is equal to 2. I'll just do that. Okay. And now, if true, A is equal to 3, else A is equal to 4. Okay, so it should just be nope, that's no, it needs to be that. If true, A is equal to 3, else A is equal to 4. Okay. I don't need a B. Don't need a B at all in here. Else A else a is equal to 4. And then lastly, of course, I need my a, semicolon. Yeah. So how should this behave? Alright. This one's going to be 13, 14, 15, 16, 16, 15, 14, 13. I'm expecting all but one to fail. All but one failed. Okay. So, first of all, 13. A is equal to 1. If true, A is equal to 3. It should equal 3, and that's right. Okay, if true, and if false, that's not true, else A is equal to 4. It should have equaled 4, and it did, and we did not get an error for P14. Okay, if false, it should just exit, and so that should give us a 1. And then the last one, A is equal to 1. If false, see, the point is this else should be bound to this inner false, and so it should have A is equal to 1 as well, and it does. Okay, that means at this point, it took us a long time to get here. We have if statements. We've got if statements that can have curly braces, code blocks, or no code blocks, which is important. We're going to have this same issue with, or the same thing that we have to deal with while statements and all that other stuff. Well, you'll see. But no, I know this was big, but we have if statements. All that we need are loops, and we can take over the world. You say, is that really good enough? Just if true, if it makes you feel better, we will add one more, and we will call this number 17, and we'll say A is equal to 1, B is equal to 2 if A does not equal B, it does, but if it doesn't, it doesn't equal, so A is equal to 3, and we should get an A is equal to 3, and of course we should get a 3 for the first one, and the second one we're going to say if it does equal, but it doesn't, so it's going to stay at the value of 1. And now that will be just 2 more to show that it can actually do expressions in there and not just true and false. But yeah, that's it. It works. I'm so happy. I'm like, oh my goodness, I'm tired. So let's wrap all this up, shall we? What's our status? As always, make clean, make test. While that's running, we're going to check our diff, get diff. That all looks right. That all is right. That's all right. That's all right. We're good. Everything's passed. If else and source AST node. If else and what? Oh. Oops. I told you I'm getting tired. It should have been get add. We're adding everything in, and we are going to say add if else support to the language. Big thing. Remove the docs, make docs-PDF. There we go. And if we look at our classes, we have our if else. There we go. Parts that we need. Yeah, it's working. Okay, so last but not least, there's our get tag-a episode. What is our episode? I never remember. Episode 26. I would have called it 25. So episode 26, and our message. Our message is episode 026. Git push origin episode 026. And because I'm always curious, it's climbing up there. You start adding all these together. 3200 plus 12, that's going to be 44 plus 7, that's 5100. Well, they're blank lines, but they're there. I had to put them in there somehow. That's all right. Well, we made it here, and believe it or not, the next steps will be easier. The big issue was figuring out how did I want to do those, get the size, you know, did I want to return the size, and I probably wasted, I don't know how many, 20 minutes, and don't worry, if you've seen this video, you'll know that I fast forwarded through that part, and so that means I gotta edit that video now. It's almost 2 a.m. Who wants to do that? The links I go through to give you live coding. Anyway, as always, you know what, I enjoy this. I love coding, and I'm hoping that it's beneficial to you to get to see this. It's not fast. It's not streamlined. It's thinking through problems, and yes, even though I'm familiar with them, and even though I've been coding for decades at this point, yeah, C++ isn't my, I've done it off and on through the years, but I'm having to learn the new parts a lot, and that's why I'm doing this, right? Above all, hey, I hope you're having fun. And as always, thank you. Have a great day. Bye.